Welcome, this is my latest project, a portable mortiser which will allow me to cut mortise and tenon joints in a fast and convenient way. I've called it X-Motion Portable Mortiser in reference to an innovative system that lets me move the router in the X-axis by turning its front handle. I've installed a couple of springs to achieve the necessary recoil to push the router back to its original central position. Apart from that, the extra tension exerted by these springs makes it easier to mill wood. Originally, I thought of using 4 springs, 2 on each side, but after a few tests I noticed that 1 spring per side is enough. The total x-axis range on each side is 15 millimeters. The movement can be adjusted with this screw fitted with another spring so that it won't move due to the vibration of the tool. So the total length of the mortises will be 30 millimeters plus the diameter of the router bit we use. For example, if you use a 10 millimeter bit, you can make mortises up to 40 millimeters long. In my case, I've logged the x-axis movement to 10 millimeters on each side, which I think will be more than enough. In this lower shot, I'm going to make an open mortise, where we can see the mortiser in operation more clearly and how long it takes to make a mortise. These are the L-shaped aluminum pieces that will act as guides for the x-axis. I cut some grooves in them so that I can adjust the hardness of the motion. With these wing nuts, I can adjust the height of the fence. Its maximum height is 35 millimeters, which means I can cut mortises in the center of pieces up to 70 millimeters thick. I cut a piece of metallic measuring tape to adjust the height of the fence more accurately, where 0 is the center of the router. If I want to make a mortise in the center of a 40 millimeter thick piece, I'll have to adjust the height to 20 millimeters on the measuring tape. I glued sandpaper on the base of the adjustable height fence to achieve a better grip. And I've also installed 2 threaded inserts which will allow me to attach these 2 pieces to cut mortises into smaller pieces. Another indispensable element is the depth stop. I've made it out of a spring and a little aluminum square bar with 3 depth steps, one every 10 millimeters, for a total milling depth of 30 millimeters. I think that's enough, but with some adjustments and the right bit, we could cut mortises up to 40 millimeters deep. We could also make another, more granular square bar with 5 millimeter steps. The handle can be detached to make adjustments or use a different square bar. By loosening these 2 screws, I can remove the router. This router has a 65 millimeter spindle mount, but this design allows me to use the router with a wider spindle mount, up to 85 millimeters. The mortiser is easy to dismantle and reassemble, which makes it easy to build or repair any parts if necessary. I've used some self-lubricating sleeve bushings to also achieve depth motion in axis Z. I've also installed a dust collection system which works really well. Mounting the router on the mortiser is very easy. This model has a part that juts out at the front to lock the router's rotation and to loosen the bit. We must turn it to one side so that it won't get in the way while working and to achieve deeper cuts. Once the router is in place, it's easy to change bits without removing it. These are the kinds of bits I'll be using. They're double flute and straight. I'll use 4, 6, 8, 10, and 12 millimeters, but other diameters can be used. We could also use roofing spiral bits. They cut better and allow us to remove wood more efficiently, besides leaving some grooves in the wood which make gluing it easier. The only problem is that they're impossible to sharpen in our workshop. To attach the bit to the router, you only need to activate the Z-axis and insert it through the front of the mortiser. Once it's been attached, it's easy to adjust the bit's position in the router in relation to the mortiser. That is why I made this stop, which allows me to leave any bit 3 millimeters away from the front of the mortiser. With this and using the depth stop, I'll always mill deeper every 10 millimeters. Now I'll show you how to use the mortiser by doing a few tests. First, I'll mark with a pencil the position of the mortises I have to cut. Now I'll measure the thickness of this piece of pine wood to adjust the height of the fence. Whenever we're working with this mortiser, we must always hold down the workpieces firmly, because in order to achieve good performance, we must exert a lot of force. I'll adjust the Z-axis depth stop and position the mortiser on the mark. To move in the Z-axis, we must push forward with our right hand as low on the handle as possible. The X motion is done by turning the handle with the left hand on the front of the mortiser, using at the same time the weight of our body, by tilting to one side or another. The process is quite easy to replicate after a few tests. Now I adjust the height of the fence again to account for the thickness of the new piece I'm going to mill. I'll hold it firmly on the workbench and proceed just like before. Making these kinds of mortises with a router and into the end grain is significantly more complicated and requires a little more time than if it were done the other way, but with a little practice you can get good results. Now we only need to test the joint, and it seems to be perfect. I made tenons in my workshop with leftover pieces of beechwood from another project. I rounded the edges out with a table router. Of course, I could also use this mortiser to make dowel joints. I only need to lock the X-axis with the screws and proceed just like when I cut mortises. This is the 3D model included in the plans, which you can buy and download on my website if you're interested in making your own mortiser or supporting my work. It's fairly complex with very small pieces, which means you will need to have some experience and some tools in good condition to achieve a good result. In order to show off how the mortiser works, as well as all it can do in a little more detail, I'm going to make a little stool using ash hardwood. I've got all the required pieces to size, and in this case I'll be making 10 and 6mm thick tenons. After marking the position of the mortises, I proceed like before with a 10mm bit. Now I'll use a 6mm bit to cut the rest of the mortises. Since some pieces are small, I'll use the mortiser's attachments, which will help me cut them in a more comfortable and accurate way. Now all that's left is to cut the tenons to size and glue all the parts of the stool together. I'll also use some 10mm pieces of tenon to screw on the stool's seat. I suppose you all know there is a portable mortiser by a famous brand on the market. I think this homemade version could be a good option for a workshop that doesn't use a mortiser too often. If we make the tenons in the workshop, we can save quite a bit of money since it's a fairly expensive tool. I think the result is acceptable, and I managed to build it in a reasonable amount of time. Now I'll show you how to build the X-Motion Portable Mortiser. First off, we must cut all the pieces to size on the table saw. I've also printed the templates on paper to glue them on the board and mark all the cuts and machining processes. I'll start by building the adjustable height fence and the X-axis drive handle. I'm going to use double-sided tape to join all the pieces that are the same, so that I can machine them all at once. This way I'll make sure they're exactly the same size. I drill all the holes and machine a groove for adjusting its height with a 3D router. We could also do this with a handheld router and guides. I sand the edges with a disc sander and make sure they're square. I also drill the holes for the drive handle and for the threaded inserts. I also cut and machine the rebates to install an acrylic plate that will allow me to center the tool. To join the pieces together more accurately, I'll use a piece of glass and cyanoacrylate as a support. When the cyanoacrylate is dry, I'll drive some screws to strengthen the bond. Now I'll cut and machine the pieces for the drive handle. I'll also make all the necessary holes and cuts on the handle's acrylic. After applying a couple of coats of nitrocellulose lacquer, I can assemble all of the pieces of the adjustable height fence. First, I'll fasten one of the round plywood parts with a nut on which the drive handle will pivot. I screw the acrylic on the other part of the handle, fasten a locking nut, and make sure everything works as intended. After cutting and machining the acrylic plate that will allow me to center the tool, I fasten it in its emplacement with screws. Now, using double-sided tape, I'll attach some P320 emery cloth sandpaper for improved grip when using the mortiser. I'll also make a line in the center of the acrylic to help me center the mortiser on the pieces. It's time to machine the two sliding pieces that allow for X-axis movement. Once more, I glue them together, drill all the necessary holes, and machine them. I finish the job with a jigsaw and make them exactly the same with the disc sander. On the front piece, I make all the necessary countersunk holes so that I can attach it to the adjustable height fence. In the other piece, I'll drill some holes so I can later make rebates to place the return springs in. Now I mark the position of the hole for the steel rod where I'll insert the springs. I clean the rods with solvent and glue them on the cyanoacrylate. Now I'll cut and machine the small pieces that will allow me to attach the adjustable height fence to the rest of the tool. On the table saw, I'll cut some grooves so that I can insert the screws of the L-shaped aluminum pieces. Also on the table saw, I'll cut a recess for the other aluminum profiles. Like earlier, I'll join together and screw the small pieces to the big board. I'll also glue on another 2 pieces of plywood to make this piece thicker. Once the glue is dry, I'll apply a couple of coats of nitrocellulose lacquer so that the pieces will slide better. I cut the aluminum profiles to size and make all the necessary grooves for the mechanism that will adjust the stiffness of the X-axis movement. Now I'll make sure everything is working correctly and that the sliding is smooth enough. Here, instead of varnish, we could use the kind of aluminum tape used in industrial refrigeration, or even glue on a 1mm thick aluminum plate or HPL. I screw on the aluminum profiles, leaving a few tenths of separation to make sliding possible. I've numbered each profile so I can find where they are if I ever have to take the tool apart. Now I can test it and see if everything is working as intended. It's time to cut all the L-shaped aluminum parts on the table saw. I pre-drill all the holes and thread where needed, using a bit 0.5 millimeters less thick than the screw. I have to trim the screws a little because I couldn't find any shorter ones. I put the L's in place and marked the positions of the other holes with a marker pen. Now I'll cut the X-axis return springs to size and put them in place. I'll also fasten a small screw that will act as a stop. I fasten the aluminum L's with screws and insert the screw that will allow me to lock and adjust the X-axis. I apply some cyanoacrylate on the head of the screw so that it won't go loose due to vibrations when it's in its most open position. And now I'll cut and machine all the parts that will fasten the router to the mortiser. I'll drill a hole for the spindle mount with the router itself, and a jig for routing circles because I don't have a bit of the exact diameter. Now I'll drill holes for the self-lubricating sleeve bushings that allow for Z-axis movement, and finish machining the pieces. Now I'll insert and glue the bushings with cyanoacrylate. To join the two plywood parts together, we must ensure the rods slide correctly along the bushing sleeves, so I make certain of that before screwing on the middle parts permanently. Next, I'll pre-drill the holes for the rods on the other side of the tool. I'll use a bit 2 millimeters thicker than the rod, so that it will have some play and can be adapted to the spindle mount. I'll drill threaded holes on one of the ends of the calibrated steel rod, and on the other end, I'll machine some small cuts for a better bond. Now I can glue the rods with epoxy adhesive, using the spindle mount itself as a reference. I insert some plastic washers I had lying around in my workshop, cut the springs down to size, and see if everything works as it should. With a table saw, I'll cut some grooves on the tool's handle, where the Z-axis top will move. Then, with a column drill and a handsaw, I'll make a groove for the screw that will allow us to lock it. I finished drilling and machining the rest of the cuts for the handle. I'll make a depth stop out of a square aluminum bar. I couldn't find a solid aluminum bar, so I'll fill in the hole with a strip of wood. I'll glue the printable template on and make all the cuts that will make it possible to lock the routing depth. I prepare the aluminum plate and screw it to the handle, and after taking measurements, I fasten the whole set to the spindle mount with screws. With a thin metal plate and a spring from the battery compartment of an old electronic device, I'll fashion a sheet spring so that I can use the depth stop. Next, I'll cut and machine the two small plates to lock the routing depth. With 2 pieces of plywood, I'll make parts that will let me cut mortises into the end grain of small pieces. And I'll also prepare the dust collection system. I'll cut and machine the plywood pieces and also the transparent acrylic one. Finally, I've noticed it's not easy using the tool when cutting mortises into small pieces, so I'll install a zero clearance on the front of the mortiser. And that's all for today. Thank you for watching the video through to the end. I'll see you soon.